Okay, we'll go ahead and get started here. My name is Matt Sump. I'm here today with Joe Julian from our office, who's our Cimco lead. Today we'll be covering what's new in 2024, the Cimco Verify / machine simulation product, and also some probing for mill turn machines from the Cimco probing product some of you might have already heard of.
Today we're going to be going over a few topics. One is going to be the what's new in Cimco 2024. Kind of run through a little bit of the differences between 2023 and 2024, some new features for you guys. We'll also be covering the Cimco Verify and the Cimco Verify machine simulation, as well as the G-code machine simulation that runs inside the Cimco editor. And as well, to finish up, we'll cover the Cimco probing for mill turn, which has just been released. I believe the trial release was about 3 or 4 days ago. So you guys are on the cutting edge here. So we'll go ahead and get started. First topic, we'll cover the what's new in 2024, and basically what we've seen is we've seen a lot of back end improvements and functionality increases here. So we'll also be showing the NC Base web client, which will be our first topic here. So if you're familiar with NC Base, it's going to be our revision control system. And typically what we've done is we've always had to open it up inside the Cimco editor, and we've accessed the database through your PC. In version 2024, we've added in a web client for this. So if you have a tablet out on the floor, the operators can either send programs to the machines, review any changes that come back, or actually view some of the setup documents here. So for instance, we've got files like, let's take, for this Haas example here, we've got this file S10003. So we've got our NC code displayed here, and then we've got like some setup information, some of our tool lists that are auto-generated here. So what we'll be able to do is, instead of the standalone client, we can go over to our browser. And basically, this is going to be an address that is the server where NC Base is installed on. So I can go ahead and log in with a specific account. And I'll be able to see the programs just like I had it shown in my editor here. So the same thing goes for our NC files or for the setup information. It's all going to be displayed, whether that's on a tablet or on a kiosk somewhere on the shop floor for the guys to use. Very good feature. We can have pretty much all of the functionality with NC Base, except for we can't really edit any of the code here. It's basically going to be a tool for us to pass this information or read it in before we run it on the machine. So for example, this file, if I wanted to send this off, I can hit this here. This program is locked. Since I'm under an admin profile, I can override that. So I could say yes, and then on my server, you could see that the file is sending through our DNC Max client. Another feature that was just added in here as well is we do have some options for finding all of the locked programs, finding all unlocked programs, or finding any files that were deleted out. So what that means is we have a couple options for deleting files inside of NC Base. What we do is we can either purge this file, which completely deletes it, or delete it, which keeps a record in the background for us to view later if we wanted to ever restore that file. So if I choose to delete this one here, and then I go ahead and search for it in my web client, so I'll search for 1003 again. I can't see it inside of here. But if I go into my search tab up top, I can find deleted, and you'll see the program that we've seen here. So if you're trying to request a file, or if we wanted to send something that may have gotten deleted, it puts it into this offline directory here, and on the standalone client, we'll be able to revert that back. So in here, we can say find deleted, and then we can say undelete. And now back into the, instead of finding the deleted now, we can go ahead and just do a clear search. And I'll clear this up, make it easier to see. We could see that program is back into our database and ready to be sent out to the machines. So a really nice feature, kind of keeps it a little bit cleaner and a little bit more clarity for the operators for what they're trying to do. So inside of that NC-based client, you'll have the same permissions that you'll have as well with some of the user groups that you set up. So I'm under this admin profile. So I'll log out of this and I'll look at the permissions in my standalone client. So I've got a few user groups set up. I've got Fanuc users and I've got Haas users. And you can see this account Bob is under this Haas users. So if I log into NC Base and I log in under Bob's account, you'll see that the only machine group I have in here is Haas. If I was under the admin profile here, you'll be able to see both machine groups, both the Fanuc and the Haas. You can see that here. So it'll take all the user permissions that you've got set up inside of NC Base and basically allow that to kind of transfer over to the web client side. Very excited about that. In terms of any of the other editor side of things, that's where a lot of the back-end improvements have come into play, and this kind of all meshes together with some of the other examples we'll be working with. So a lot of the improvements have come in on the Backplot side and kind of catering towards the machine simulation end. So we'll be covering that in a bit here. But inside of here, a lot of these permissions that we've not seen before are actually included now. So when we see here, we've got the Haas Next Gen milling control. We can set a machine environment to that. Use some of the fast versions here. That was in 2023, but it's been kind of optimized a little bit further in 2024. So let's jump into Mastercam here. Let's take a quick move. So what we can do now is we've got the ability to program probing cycles with the Cimco probing side of things, and we can also backplot those inside of the editor as well. So what I can do is, and we'll go into this a bit deeper here later on, but we can go into our Cimco Verify Setup tab. And instead of running as machine simulation, I can actually I can post out these cycles and pull them into my Cimco backplot right off the bat. You can also bring in your tools, your workpiece information, fixturing, and then any stock that you've got as well. So basically this works. I can select any toolpath in my manager here. And all I do is once those are selected, I'm going to hit Run Cimco Edit. Let me just make sure this is closed out first. If I hit Run Cimco Edit, it'll trigger my post to post out these cycles that I have selected here. So I'll say no to this. We're going to just post out the probing cycles. And this will automatically start my Cimco editor in the backplot. So you'll see my stock that I had set up in here, and then some of my probing cycles. You can see these are all G65. These are not actual G code, but the Cimco editor now actually recognizes these probing cycles in the window, and we can actually view these here now. So in using that Cimco Edit or Cimco Verify launcher, we can actually pass over all of our workpiece information. You can see here I can toggle on and off my workpiece, my stock inside of here. So for this, since we're going to be probing the stock before we start machining, I'll go ahead and hit a quick play on the backplot side. And right there, it's going to be doing a tool change. And you can see my probe, which is brought over from Mastercam, excuse me. And if I speed this up, you'll see the code run through here as we're doing some of these probing cycles. So this is going to be basically setting my work offset to the center of the stock. It's going to be doing our X measurement. This is going to be doing our Y. This is going to touch off in Z for us. And this is a 5-axis part here. So this is going to be clocking in our B axis on the top. and then going to be clocking in our C-axis to make sure that we're actually straight in our vise. So within that, typically Cimco Backplot has just been on the G-code side of things, but if we have some cycles that you have already either written up or you're using Cimco probing to create those, then we can actually backplot these out now. So very excited about that. Okay, so if I close this out, I can actually add this into my database straight from here. So once I'm posted out, you can see it posted to my Mastercam window here. I can also hit Add Current Program. And basically what this does is this will add this into my NC-based database. So I'm S1101.nc is my file name. And I can pick which machine I'm under. I'm under that host group here. So I've got some part number, drawing number all kind of pre-configured here. So you can also have these if we want these as required fields in here. It's going to yell at us to say, hey, we need to specify this before we add it into the database. So if I hit add into here, it's going to pretty much prompt me if I make a change or add a program under this profile, but we could say okay. And then under my Explorer, I can then search for 1101 here. At that point, if we look at our NC base web client, we've got our file, and we can send this off to the machine at that point. So we're kind of coming full circle. We're getting all of the backplotter side. Once we've verified that off in our probing cycles, we can then go pass that off to the machine with that web client here. So like I mentioned, we're basically all conglomerating. A lot of the back-end changes that were made in 2024 are going to help some of the Mastercam integration side. So we'll jump into the next topic that we're going to be covering here, which is our Cimco Verify. And what Cimco Verify is basically made for is to speed up the verification process in Mastercam. So potentially we've got a good sized file here, but I'll jump into a bit of a bigger one. And you can see here that I've got this mold cavity, and it is quite a large file. We've got 7,900 kilobytes of toolpath on this OptiRough, and then just increasing out as we go into our finishing op and then our pencil op to clean everything up here. So if I tried to verify this off in Mastercam, it's going to take a bit to pull that all into the Mastercam Verify. The difference with Mastercam Verify versus the Cimco Verify tab up here is that Mastercam is actually using the CPU, while Cimco is using the GPU on your programming workstation. So what I mean by that is if I backplot this off, or not backplot, excuse me, if I simulate this in Mastercam, so you could see that we're loading in this data still. We could definitely hit play on this and let it ride. But as we get into some of this more complex and larger parts of the toolpath, we're going to be straining our CPU quite a bit. You can see a big jump here. And like I said, we're still loading in this file. So this is the whole toolpath. If I speed this up all the way, we're getting, so the stock is being removed here, but we're not exactly seeing that real time. So this is all still being pulled in here. I think we're roughly 30 seconds or so, maybe a little longer than that, and we're not even 60% of the way there. My computer also sounds like it's about to take flight. So what we'll do is we'll show the Cimco Verify and how that's a little bit different here. So if I go up into my Cimco Verify tab, I can choose a couple different options inside of here. So we covered in this previous file, we covered the run Cimco edit inside of there, which posts out your file. But the Cimco Verify, what we can do is actually, we can say installed machines, or we can even choose machine simulation on this. And then we can pick our workpiece from a level, fixture from a level, or if we wanted to select that on the screen, we can do that. Or if you have an STL kind of located somewhere on your network or on your desktop, we can also pick that. Well, same works with the Run Cimco edit. If we select all the toolpaths here and then we say Start Verify, so this is going to pull in my toolpath. And let me move this out of the way. I can then speed this up, and the whole toolpath is loaded in. And by the time we even got to that second op inside of there, it looks like we got some stop conditions going here. So this is an operation change. I can toggle this on and off if I want to stop it between my different toolpaths. If I turn that off, we're going to see the full tool motion and the stock being taken off in real time, even on very large files like this. And basically this file is completely done before the Mastercam Verify loaded the entire thing in there. So basically Cimco is using the GPU to do this. So a little bit of a spike, but it's more of a powerful option to do this because you're already programming with a workstation that's got one of these video cards equipped. So the Cimco Verify option is basically using that instead of the CPU. So within this, you can do things like hide or show the workpiece here. We can even look at a compare option here as well. So if I did like a stock compare, and this is a metric file, so I'll keep this at 0.2 millimeters. But if I activate this, what this is going to do is it'll basically scan my entire model in the toolpath that came out. And within this scroll bar here, it'll give me kind of my tolerance here. What's also nice is if I hover over any of the portions of the model itself, it's going to give me what my finish tolerance is going to be. So let's say maybe the tool was a little bit too big in some of these areas here. If I hover over this, I can see exactly how much stock was taken off here. If I choose to show my workpiece, I can also do like a cross-section view. So if I do like a Z positive here, I can pull this up, and you could see inside of this fillet here that we've got some extra stock left, so we might need to go in and change that operation up a bit. Same goes if you wanted to do like X plus maybe, if you wanted to look at it from that view. You can do that here. You can kind of see where our model is differing from the workpiece. So
Hey,
a lot
Joe,
speedier for you guys if you are using. Yep. Oh, sure. Go ahead, Matt.
I just answered for everybody there, but Elliot asked just to clarify for everybody that, he asked, is this an add-on for Cimco and Mastercam? And I said, yes. And, currently you're doing the verify portion, but then there's a second layer. And this can be a separate install from like the other Cimco products, correct?
Yes, that's correct. So the Cimco Verify actually works on a completely different license than your Cimco Editor license, or if you have like DNC or NC Base or anything like that. So it's completely separate from that, but it is tied to your Mastercam SIM number, that Cimco license for the Verify. So basically, you have to be a Mastercam user to run this. It's kind of like the long and short of it. Any
Thanks,
follow-up questions that they had, Matt?
Nope, we're good.
Okay, awesome. Appreciate it. Okay, so we'll jump into the next portion of it, which is going to be our Cimco Verify for machine simulation. So what this is doing is this is going to be basically a kind of a mirror of what you're using if you're using machine simulation in Mastercam through the module work simulations. So with this particular file, if I wanted to run this on, actually let's switch over to a different file here. So for this one here, I can select all my toolpaths inside of this window, and before we had just the Cimco edit configurations when we're posting that out. We can use some generic machines, which will be kind of like just your normal basic machines inside of there. We'd also have to have the machine simulation on, and then some of these options become available to you. We also have the installed machines option. So if you built up your machine or you installed one from Cimco themselves, then these will be where they're showing up inside of this drop-down window. Now, within the machine installer here, we have a few pre-configured options for the Haas machining centers usually. So basically the long and short of it is some machine tool vendors, they choose to keep their models pretty locked down. Haas in this case, you can go on Haas's website and you can find a model for your machine and download it today. So basically what Cimco wanted to do is just give a baseline. So Cimco has a good amount of the Haas machining centers already available for downloading here. So in particular, I have this one for a, let's say a UMC 7 or 1000 here. It's got some 5-axis toolpaths on here. But what I can do is if I have this machine simulation option checked on and I have all my operations selected, I can choose Start and Verify inside of here. And what this will do is this will basically take the extents of your machine, your limits and everything. And you can see that in our scroll bar here in our access control. So where the machine is at currently in the NCI file, you'll be able to check and see if we're going to be violating any of those limits inside of here. So the first operation in our toolpath manager was our probing operations. So inside of the machine simulation side, we'll go ahead and give that a quick play. So just to reiterate, this is not the G code. We do have an option that we'll be going over for the G code side of it, but this is going to be kind of a solution that uses Cimco's GPU verification side, but it's using the NCI inside of Mastercam. So you'll see all of the stock being taken off here. And then our rotation on some of the 5-axis on some of these bosses here. Just like we saw in the original verify, we can choose to display our workpiece or not. Now, what's nice about this is you can still do that compare option inside of here. So if I activated this, and it's going to verify my stock versus my workpiece. So you could see inside of the model, if I hide my workpiece, you could see in this this ramp that I did that we're kind of violating a little bit here. So before we posted that file out, what we can do is we can recheck our toolpath. So I believe it's going to be this contour ramp here, and you can see that the lead out in this one is a little bit wide. So what I can do is I can go in and change that in my, let's see here, I believe in my lead in lead out page. And let's verify that this looks good for us. Let's say 40, and then apply that. So that looks like it's following fairly close to our initial path here. Once that looks good, I can go back into the Cimco verify. And we can start that machine simulation up again. So for this, I'll just jump to the complete end of the program instead of playing it out again. So you can see it basically does that in real time. And it doesn't look like we're violating this any longer. I could show the workpiece and we're very close. I'll go back into compare though and hit that activate just to be sure. And we are good to go. We got a lot of green here. So it's a nice option if you are using machine simulation to use some of the methods that Cimco has developed for some of this toolpath optimization, some of the smoothing techniques that they've implemented here. It's a lot faster than what we've seen before on the Mastercam side of things. So I'll jump back in. Let's see here. Okay. So on the machine simulation side, we've covered basically the kind of the replacement almost for the Mocksim side. So that would be for just the NCI file. What we can actually do is instead of the installed machines, which will open up in the Cimco Edit Verify, we can do the Cimco Edit configurations, and then we'll be able to choose a machine type inside of here. So if I'm under, let's say, Haas UMC 750, which is the post processor that I've got pulled up, I can look at my editor configuration. I've got Haas UMC 750. And in Backplot, the machine that I have selected, you could see that it says bundled on this. And then my control is the next gen control milling. So what we need to do in this is, if we wanted to get the Cimco machine set up, machine simulation set up, we would have to have a file type here for the Cimco edit. So that would be under that UMC 750 like we saw in Mastercam here. That's going to correspond to this one. And then inside of here is where we would select our machine simulation. So I've got machine models that are installed or custom machines that are in here. These are kind of like our baseline to start with, and then we can also add these in here as well if we need to create something up custom. But once I've got all that set here, and I've got my workpiece selected, everything should carry over from our first example here. Instead of start verify, since I have this selected, I can make sure machine simulation is selected and then hit run Cimco edit. So what this will do is this will open up our machine simulation if we have that bundled machine configuration selected in here. So I've got my base hidden right now, but if I make that visible, you'll see the full model of your machine. I'll turn this off so we can make sure we can see all the toolpath run here. But my entire file is posted out, so I can say play. It's going to grab my probe to start. So that's probing our stock, and you can see that the machine simulation is running through the code as we do this. Same goes for, and I'll slow this down so we can see here. So the G code is being processed based off of the control type here, and then our simulation is being run from that bundled machine sim. So this will be ramping down, spot drilling some of these, chamfer milling these, chamfering some of these holes. Let me give this a quick pause. Oops. Pardon me. I think I stopped that before, so let me redo that here. All right, so play this here. We'll try to get back to where we were at. So within this, I can choose to either hide my workpiece, just like we saw in the Cimco machine simulation without the G code, and we'll see all the code. This is basically our stock that we have left inside of the vise. Same thing goes if you wanted to remove any of the fixturing side. I can toggle all this stuff on and off. And what's nice about using the Cimco Verify launcher here is this will actually take all of this information and generate STL files that Cimco Edit's going to be using. So all this is directly pushed from Mastercam, and we're also getting our tool profiles passed over as well. So in the tool setup section here, you'll see all of our holders that are selected and all of our tools here as well as that probe, and it pushes this all direct from Mastercam, so that integration is super nice. So I'll slow that down. We'll let this kind of complete here. It's going to be engraving our Cimco logo on the end here. So you can see that it is red inside of here as well. That's basically because these threads were not actually defined in the model. So anytime that we do have a collision, quote unquote collision here, it'll actually make the tool red inside of this. So if you see that in your simulation, you can either do collision, or if we wanted to do any of the particular types of collision, like rapid to stock, stop spindle cuts, any of this stuff here. We also do have the limit functionality too. If you did violate any of your limits, then that would stop the simulation for us. Pardon me, this is not liking what I'm doing here. Apologies, but I think I just got too much going on. But yeah, that is the Cimco machine simulation. Basically, going to be a good replacement for something that's, let's say, on the more expensive side, the Vericut side of things here as well. So we do have some bundle pricing for this, and that'll include the Cimco Verify, the Cimco machine simulation, and the Cimco editor here as well. So if you guys have any questions on that, or you have a specific machine that you're looking to simulate, please get in touch with us, and we can see if we can't work something out with you guys. All right. So last topic we wanted to cover here is going to be our Cimco probing for mill turn. So I'll just give us a quick save so I can make sure my computer doesn't blow up on me here. Won't save this one. And I do have the a mill turn file pulled up here within Mastercam. So I mentioned at the beginning of the webinar here that we've got the ability to use Cimco probing inside mill turn operations. That just came out just a few days ago, actually. So they've put a lot of work into the development side of things, working with Mastercam directly here to get some of the functionality all taken care of. If you're familiar with mill turn, we are using a machine environment to post out any of your files, and it's also going to be built in with your simulation. So it doesn't work exactly like a normal post would work. And for that reason, you can see some of these Cimco probing operations are ghosted out inside of here. So what we do inside of that is basically to make mill turn function with the Cimco probing side, we're actually creating a point operation that is corresponding to this Cimco probing operation. And this is going to work very similarly to your XML side of the post. So basically we have our machine file here. And what this will do is this will actually access this probing.config file. And this will have your control name, the controlled subname. This is a lathe here, the machine type, and then our access combinations. So this will act as our basically the XML of the post. So when we're doing this, we can, I do have a helix bore operation that's going to be machined on this angled part of the face here. So let me rotate a bit. So if I'm underneath this Cimco probing side of things here, and I can pull up either the workpiece datum, and the workpiece datum, if you're a little unfamiliar with the Cimco probing, workpiece datum is if we're setting any work offsets. So if we're trying to touch off from the center, kind of an X and Y for a rectangle, we can do that here. If we're doing like a boss, or if we're trying to just get Z or a specific axis value, we can touch that off, and that'll actually write that to our work offset. For this particular one, we've already got that set up, and we've machined this helix bore inside of here. So I'll go in and I can say I want to measure this diameter inside 4 points. And you can see it creates that point operation before we even do anything here. So in this case, I'll select my probe, and I'll go in and I will select an arc. And then basically from that machine configuration, probing.config, we've either got the upper left or the upper right axis combination here. So for this, I'll choose my upper left. and then I'll select this arc. So after this, it'll kind of grab because it knows where that arc is in relative to space. So I can say okay to this, and I can pick one of my mill-turn planes inside of here. So I'll say okay to this. And then just like in any other Cimco probing operation, we can give this a clearance height inside of here. And then we can bump down our measuring height to make sure that goes into our part. So I believe we're close here. So that should be touching off in all 4 of those quadrants here for this feature. So what's nice about this is you also have the opportunity to specify what type of work you have. So whether it's a C-axis face, Y-axis face, cross, or the plane rotation. For this example, we are rotating this plane inside of here. So we'll leave that as is. But you do have the same opportunity to do any of the measurement results if we wanted to spit this off to a variable on the Akuma control. Or if we wanted to implement some remachining into this as well. So when we first started, you could see that I machined this out with the helix bore operation. So I'll go in and I'll put some if-then conditions on that toolpath. So basically, Cimco probing is going to ask you, what are my 3 scenarios? So I've got, if I'm scrapped, let's say I wanted to do an M0 just to stop the machine. I can do, what happens if this part is undersized and I need to remachine that? So what I can do is I can go to a specific operation. And in this case, I can check my toolpath manager, but I believe it's this helix bore operation, number 14 in our list. And then if we're within tolerance, then I can continue on. Oops. So what's nice about this here is once we have this operation selected, this becomes automatic in this tool offset number to be updated. So this will use the tool offset for the tool that just cut in op 14. And then within our greater than, less than remachining tolerance, that's where we set if we're high or low inside of this. So I can give this, let's say 0.02 millimeters. So I'll say okay to this, and my operation is completed. My toolpath is ghosted for the actual Cimco probing op, but I do have this point operation now. So if I go ahead and select that first helix bore operation, the point and actually this doesn't necessarily matter because we are not posting this, but if we do G1, so open just like we have in mill-turn, if you're familiar. So you can see it's processing all this. And then we've got our pre-simulation here. So you can see in our timeline the different operations. See it's that point operation, which is our, if I zoom in a bit, you can see that's highlighted for our probing cycle. So for both of these, I'll go ahead and launch my simulation. So you'll see I've got my Kuma Multus machine environment here, and we've got our part. So I'm going to put some stop conditions on this for a tool change. And I'll go ahead and speed this up while we're playing through the, oop, that went pretty fast on me. So you can see it's doing that helix bore operation just like you would expect to see in mill-turn. And once we finish that up, I have the stop conditions on here, so I'll bump this down so we can actually see our probing operation. So that's going to be doing our tool change here, and I'll be a little careful with this. So you can see we've extracted our tool from the changer. That'll be our probe. And if I zoom in on this feature, mill-turn side is going to be coming down and probing that feature for us. All right, so that completed out. So let's say I'm happy with my simulation and my mill turn side of things. I can then go in and I can say post. So this will take our post and it will post out both the helix bore operation and the Cimco probing inspection cycle. What I want to point out to you guys is the remachining end of it. So you can see here we've got a restart label, NL AAA. So I'll go down, excuse me, and once that helix bore operation is completed, it's going to post out our probing cycle here. And this will turn on our probe. This is going to be our protected move to our safety zone. And then our 9814, once the protected move is where it's supposed to start, it's going to call up our probing cycle. And then protected move back out and turn the probe off. So this is going to be where our tolerance comes into play. So on the Akuma control, that V83 is going to be our error for the feature that we just measured. So we're stating if that variable is greater than 0.02, then go to this particular label. So NLAAB. NLAAB is our scrap label here, which contains that M0 that we selected in our toolpath. So that if I pull that back up again, it's going to be our M0. Now, if we're less than, it's going to be NLAAC. So if our error is less than that value, then we're going to go to this one, which is our remachining label. And then at the beginning of our file, remember we saw the NL AAA, which is our go-to for the helix bore operation. Now the tool is going to be selected in this cycle, so it's going to be updating that work offset inside of here. And then we're going to be, it's going to go to this label and then remachine that after we adjusted the offset. So it makes it very simple to work in some automation into some of your processes here. And this is not just for the mill turn side. This is also available in either the regular lathe or the mill side as well. So if you're having any trouble with probing any of your cycles, or you want some justification or some peace of mind with posting some of these cycles out, I know it gets pretty expensive to replace styli or even some of the modules on the probing end. So if you're having any trouble with that, we'd be absolutely glad to help you. Alrighty, so that's a brief example of what we can do with the inspection end of it. I did mention that we do have any of these cycles available for setting work offsets, and we've got quite a few options inside of here. So if you are a mill turn user and you want to check some of this stuff out, please let us know. I did want to open it up for any questions if you guys had any towards the end here. And did anything come in here, Matt?
Nothing new since the last one.
Okay, fantastic. Alrighty, well that's I'll keep it short and simple here. Yeah, if you guys have any questions or if you need any guidance on the probing end or any of the machine simulation, we can certainly help. So don't hesitate to reach out. I appreciate everyone's time today.
Thanks, everybody. Have a good day, everybody.
Thanks, everyone.